we're going to continue looking at how to complete the square. So completing the square is a bit different from what we're used to seeing in terms of factoring quadratic equations. The standard form for a quadratic equation is the setup ax squared plus bx plus c equals 0. That's the form that we use if we're going to use factoring methods like we saw in the beginning: greatest common factor, difference of two perfect squares, factoring a trinomial into two binomials. As well as using the quadratic formula, we use this setup. Now, completing the square is a bit different. The setup has to be ax squared plus bx equals c. So in order to use the complete the square, we need it to be this setup. The other thing also, a has to equal 1. A must equal 1. So when our leading term x squared is just that, we can use the completing the square method. So as long as we're in this setup, x squared plus something x equals c, we can use completing the square. So what we do is we divide the middle term by 2. So step 1, we divide b by 2. Whatever our number b is, we divide by 2. And then we square it. And whatever we get, we will add to both sides. So once we do that, we've created a perfect square trinomial, and we solve for x by taking the square root of both items and solving for x. So once we divide by 2, square it, and add it to both sides, we can continue on using completing the square. So we're going to take a look at this particular problem. 2x squared minus 12x plus 4 equals 0. We have to use complete the square method. So what we're going to do is get it in the correct format. So here we have to have it set up so we have x squared plus x equals a number. So 2x squared minus 12x plus 4 equals 0. That's not the right setup for completing the square. I actually have to move the 4 over. So we are going to do the opposite of whatever's going in the problem. So we're going to subtract 4. And we subtract 4 from both sides. That will cancel out. So we have 2x squared minus 12x, and once I do that, I leave a little bit of space, and we are equal to negative 4. The other stipulation we have is that a must equal 1. So here we have the number 2 on x squared. That is not correct, so we have to get rid of the 2. So 2 times x squared means I must divide everything by what is in front of the x squared. So everything gets divided by 2. So the 2's will cancel out here, leaving me with x squared. And then negative 12 divided by 2, we can just turn on our calculator. Negative 12 divided by 2 gives us negative 6. So minus 6x, again a little space. Negative 4 divided by 2, we get negative 2. Now comes the part where we have to complete the square. So here we're in the correct format. We have x squared and x on one side of the equal sign, solid number on the other. Now comes the 3 steps. We have to divide by 2. The middle term gets divided by 2. So we divide negative 6 by 2. And we get negative 3. And what I have to do here is I have to square this. And then again, negative 3 squared, and anytime I square a negative number, I got to put in parentheses first. I get 9. And what I will do here is I will add 9 to both sides. So what I end up with is x squared minus 6x plus 9 equals negative 2 plus 9. Now what we have created on the left hand here, the x squared minus 6x plus 9, is a perfect square trinomial. So this means that this can be broken down into a binomial that I am squaring. Now the trick to this is actually relatively easy. The first thing I put in the parentheses is the letter that we have in the problem. In this case, the letter we're working with is x. And then what I put in parentheses is the number we got when we divided by 2. We got -3, so minus 3. So this trinomial, x squared minus 6x plus 9, can be factored down into x minus 3 squared equals, and then I just do the math of -2 plus 9, and I get 7. So what I'll do now is I need to solve for x. Now the problem we have is x is inside a set of parentheses with an exponent of 2 on the outside. So the first thing I have to get rid of is that exponent of 2. So anytime I want to get rid of an exponent of 2, I just take the square root. And because I take it on one side, I have to do the square root on the other. What this will do is the square root and the square will cancel each other out, leaving me with x minus 3 equals, and then I took the square root of a number, so I end up with a positive and negative value, in this case square root of 7. Now the last thing I'm going to do is I have to get x by its lonesome, so this means I have to move the 3. So here in the problem we're subtracting 3, so to move it I will add 3. Now 3 being a nice solid number and the square root of 7 is kind of an oddball number, I'm not going to combine them. So -3 plus 3 cancel each other out. So we have x equals, and then the solid number will come first. So positive 3 plus or minus the square root of 7. So there's my two answers. My one answer is 3 plus the square root of 7, and my other answer is 3 minus the square root of 7. So rather than just putting it up into two things like that, if I'm adding and subtracting the same number, I can just put the little plus and minus there. It means the same thing. It's a little shorthand shortcut that we like to use. So there is my answer. X equals 3 plus and minus the square root of 7. So the second problem is a multiple choice. Here we have Brian correctly using a method for completing the square, given that equation x squared plus 7x minus 11 is 0. His first step is to rewrite it as x squared plus 7x equals 11. Then he adds a number to both sides. What number did he add? Well, first of all, the setup that we're going to look at is the one that we are told he got after he wrote the first step. So we're going to ignore the first part, the x squared plus 7x minus 11. We're going to ignore that. We're actually going to take a look at the second step, x squared plus 7x equals 11. That is the correct format we need to be in order to do those three fancy steps. So the first step, whenever we complete the square, is we take that second term, the middle number, and divide it by 2. So if I have x squared plus 7x equals 11, the number in the middle gets divided by 2. So we divide by 2. Now 7 divided by 2 is not a nice number. We get 3.5. So we're just going to leave it as 7/2. So 7 divided by 2 is still 7/2. The next step I have to do is square it. Now the cool thing with fractions is anytime I square a fraction, both numbers end up being squared. Now we could square each number individually in the calculator, or we could just plug in the fraction 7/2, square it. It'll give us a decimal, but we can always turn it into a fraction by hitting math, and then our first option here to frac is highlighted, and we get 49/4. So that number gets added to both sides. So out of my 4 options here, number 2 is the correct number we came up with. Number 3, we are told x squared plus 2 equals 6x has to be solved by completing the square, and one of these 4 steps is going to be the correct one. So we actually have to do a little bit of work here. X squared plus 2 equals 6x. Now the thing with this, remember, is I need x's on one side of the equal sign, number on the other. So the problem with this is I have x's on both. Now we like x squared to be positive, so in this case x squared is positive on the left hand side. So we're going to leave it there, which means I have to move the 2 over. So first step, I'll subtract 2 from both sides. That will cancel out, leaving me with x squared equals, in this case, 6x minus 2. Now we're not quite ready yet because, again, x's have to be on one side, and I still have x's on both sides of the equal sign. So because x squared is positive on the left-hand side, I'm going to leave it, and I'm going to move the 6x over. Now I have to move it. In this case, we're going to subtract 6x from both sides. So again, I can't subtract 6x from x squared. They don't have the same exponents. We have x squared minus 6x equals -2. So this is now the correct format we need to be in order to complete the square. So we're still working with x squared minus 6x, and now I'll leave a little bit of space, equals -2. Now what I'm going to do is use those 3 fun steps in order to figure out our trinomial. So again, step 1, divide the middle term by 2. -6 divided by 2 gives me -3. And then I have to square it. -3 squared gives me 9. And that's what I will add to both sides. So we end up with x squared minus 6x plus 9 is -2 plus 9. So here we're not quite in the format we need for our problem. So here we have our perfect square trinomial, x squared minus 6x plus 9. So if I were to break this down, we have a binomial squared. Again, the shortcut to it is, the first thing is the letter we have in our problem, which is x. And then the number is what we got when we divided by 2. And we got -3. And then all I have to do is add -2 plus 9, or we can do 9 minus 2 gives me 7. This is the format our answers are in. So I need the one that is x minus 3 squared equals 7. Ends up being number 2. So that we can use completing the square to answer multiple choice questions. Sometimes we have to go a little bit further than others. Sometimes we don't have to go very far. Now, the next few are kind of review questions based on what we've done before. And we are going to actually skip to number 7, solve p squared minus 3p equals 8 by completing the square. So first thing, we have to make sure that we are in the correct format, which we are. It's just p squared. P's are on one side of the equal sign, numbers on the other. So we can actually go ahead and start doing the 3 funky steps that we need to in order to solve for p. So step 1 was to divide our middle term by 2. Now 3 divided by 2 isn't a very nice number. It's an odd divided by an even, so I'm just going to leave it as -3 over 2. And I have to square it. And again, if we don't know, again, in a fraction, we square both numbers, so it's -3 squared. We've done -3 a bunch of times. But we could also use the calculator. -3 divided by 2 squared gives me 2.25, but because we're in a fraction, I'm going to put it back into a fraction, 9/4. So I'm going to add 9/4 to both sides of our equation. So we actually have p squared minus 3p plus 9 over 4 gives me 8 plus 9 over 4. Now this p squared minus 3p plus 9/4, that is your perfect square trinomial, meaning I have a binomial that I am squaring. So what goes inside the parentheses here? Well, it's the letter in our problem, p, and then the number we got when we divided by 2, -3 over 2, equals. And then I'm going to add 8 and 9/4, so 8 plus 9/4 gives me 10.25, and because I have a fraction in our problem, I'm going to turn it back into a fraction, which is 41 over 4. So now what I'm going to do is, here we got our perfect square. P minus 3/2 squared gives me 41 over 9. I'm going to solve for P. So working backwards, I have to get rid of this exponent of 2. So I take the square root of both sides. What that does is square root and square will cancel out, leaving me with P minus 3 over 2 gives me, and again, just like when I square a fraction, if I take the square root of a fraction, I end up taking the square root of both numbers. Now the square root of 41 is not very nice. It's an irrational number, it goes on forever and ever. So up top, I actually have just square root of 41. And square root of 4, that should be a 4, not a 9. That's a 4. Square root of 4 is 2. Now again, whenever I take the square root of a number, I take the positive and negative values of it. So again, I want P by itself, so I have to move the 3/2 over. So I'm going to add 3/2 to both sides. Now the negative 3/2 and the positive 3/2 will cancel out. It leaves me with just P equals. And again, 3/2 being a nice fraction, I can put it out front. So 3/2 plus and minus, in this case, square root of 41 over 2. Now the thing with fractions is if I am adding or subtracting two fractions where the denominator is the same, I can combine the tops and put the bottom number as their lone denominator. So notice here our denominator is 2. What this means is I can just take P equals, and then what I'm going to do is I'm going to take whatever is up top with our math sign and put it as my new numerator, 3 plus and minus the square root of 41. And then the denominator in both is 2, so it just gets put together as 2. So that is actually the correct version of our answer, 3 plus and minus the square root of 41 over 2. Now you could have left it as our original 3/2 plus and minus the square root of 41 over 2. However, if you were to see this as a multiple choice question with possible answers, that is the format you will see it in. So that is completing the square. Again, it is a form of factoring and solving for a variable that will always work, just like with the quadratic formula. So both are options that you can use, specifically more when numbers are not as nice within the quadratic equations.